Welcome back to our channel. Today we'll solve a real-life example of a two-tailed z-test for two proportions. Let's dive into the question. You can message us on Telegram for any other question. A company wants to compare the effectiveness of two advertising campaigns, A and B, in converting website visitors into buyers. The marketing team collected the following data. For campaign A, out of 500 visitors, 120 made a purchase. For campaign B, out of 400 visitors, 88 made a purchase. The company wants to test if there is a significant difference in the conversion rates of the two campaigns at a 5% significance level. Here, the company wants to decide which campaign is more profitable. They want to choose one of the two campaigns. So we will statistically determine which campaign the company should choose. We'll solve this step by step. Step 1. Write down the given data. For campaign A, the value of N1 is 500 and the value of X1 is 120. The sample proportion for campaign A is denoted by P hat 1, which is given as X1 upon N1. Therefore, the value of P hat 1 is 120 upon 500. That comes out to be 0.24. Similarly, for campaign B, the value of N2 is 400 and the value of X2 is 88. The sample proportion for campaign B is denoted by P hat 2, which is given as X2 upon N2. Therefore, the value of P hat 2 is 88 upon 400. That comes out to be 0.22. The significance level alpha is 0.05. Step 2. Setting up the hypotheses. Let capital P1 and capital P2 represent the true proportions for campaigns A and B, respectively. The claim is that there is a significant difference in the conversion rates of the two campaigns. Here, we want to check whether there is any difference in the efficiency of the two campaigns, or whether are they equally efficient. The null hypothesis, H0, states that capital P1 minus capital P2 equals 0, meaning there's no difference. The alternate hypothesis, H1, states that capital P1 minus capital P2 is not equal to 0, meaning there's a significant difference. Since the alternate hypothesis uses a not equal sign, this is a two-tailed test. Now in step 3, we calculate the value of the test statistics. The formula of the test statistic z is given by this expression. Z equals P hat 1 minus P hat 2, which is subtracted by capital P1 minus capital P2. In the numerator, we have the square root of capital P hat into 1 minus P hat multiplied by 1n1 plus 1 upon n2. Now you will ask, what is this capital P hat here? Well, this capital P is called the combined variance of proportions. The value of capital P hat is given by the formula x1 plus x2 divided by n1 plus n2. Now, before calculating the value of the test statistic z, we need to find the value of combined variance. The value is given by 120 plus 88 upon 500 plus 400. After simplifying, it gives the combined variance as 0.23. Now we calculate the test statistic z. Under the null hypothesis, capital P1 minus capital P2 is 0. Hence, the test statistic can be calculated by substituting all the values. After calculation, the value of the test statistic comes out to be 0.71. Step 4, we'll draw a conclusion based on the critical value method. For a two-tailed test with alpha equaled 0.05, the z-critical values are minus 1.96 and plus 1.96. Decision rule. If the value of the test statistic is inside the interval minus 1.96 to plus 1.96, then we accept H0. If the value of the test statistic is outside of the interval minus 1.96 to plus 0.96, then we reject H0. Conclusion. Since the value of the test statistic 0.71 is inside the interval minus 1.96 to plus 1.96, hence we accept H0. In step 5, we will verify that the conclusion remains the same if we use the p-value method. In a two-tailed test, the best ever bulletproof formula to calculate the p-value is 2 times 1 minus the probability of capital Z less than the absolute value of the test statistic Z. Substituting the value of Z as 0.71, the p-value can be calculated. The final expression of the p-value is 2 times of 1 minus probability of capital Z less than 0.71. Now one can obtain the value of probability capital Z less than 0.71 from the Z table, then substitute in the above expression and calculate the p-value. Also, one can use the Excel to calculate the p-value. The Excel formula to calculate the p-value is equals 2 star 1 minus norm.s dot dist 0.71, true. This Excel formula is the same as the theoretical expression of the p-value. Therefore, the p-value comes out to be 0.477. Decision rule: if the p-value is less than alpha, then reject the null hypothesis. If the p-value is greater than the alpha, then accept H0. Conclusion: since 0.477 is greater than 0.05, we accept H0. Step 6. Interpretation. The test result shows that the calculated z-statistic falls within the range of the critical z-values -1.96 to +1.96 for a two-tailed test at a 5% significance level. This means the observed difference in conversion rates between campaign A and campaign B is not statistically significant. The company can conclude that, based on this data, there is strong evidence to suggest that both campaigns are equally efficient at converting website visitors into buyers. And that's it for today's example of a two-tail z-test for two proportions. If you found this video helpful, don't forget to like, share, and subscribe for more statistics-related content. You can message us on Telegram for any other question. See you in the next video.